The researcher Joseph von Fraunhofer, born in 1787, has brought us closer to the stars. He is considered to be a co-founder of modern optics because he succeeded in producing telescopes of a previously unreachable quality. His most important discovery has survived even to this day. Named after him, the Fraunhofer lines. They allow us to take a look into space and to understand how stars are formed. With the aim of making better optical lenses, Fraunhofer examined the color dispersion of glass. He experimented with different light sources, for example, with the sun. When sunlight enters a prism, a colorful arc appears, the spectrum. Fraunhofer developed an optical device that splits the light into its spectral colors. With this spectrometer, he could examine the colors more accurately. In 1814, he discovered tiny dark lines. With exceptional accuracy, he measured and documented 574 lines. They would be key to the success of his research. With these dark lines, he found fixed reference marks, which he could use to measure the light refraction of different glasses, since they divided the colors clearly from each other. Now he was able to produce high-quality, streak-free raw glass of a consistent quality, from which he made the best lenses. With them, he was able to build the most efficient and largest astronomical telescopes of his time. Fraunhofer died at the young age of 39. The quality of his telescopes and optical instruments remained unmatched for decades. With the Fraunhofer lines, he laid the foundation for many areas of physics and modern astronomy. After 1826, other scientists tried to comprehend how the Fraunhofer lines work. It was not until 1860 that Gustav Kirchhoff and Robert Bunsen succeeded in revealing the secret of the dark lines. By evaporating mineral chemicals, they produced colored flames. During the investigation, it became clear that each of these chemicals left its own fingerprint in the form of lines, similar to a barcode. Some of these barcodes are also found in the dark lines of the solar spectrum. The researchers found there, among others, the codes for iron and sodium. They concluded that these minerals must also occur on the Sun. But how are the dark lines generated? By means of nuclear fusion, the Sun produces an unimaginable amount of energy that emerges on its surface as light. There, this light is sucked in or absorbed by the chemical elements. In the process, they leave their characteristic fingerprint on the solar spectrum in the form of black lines. That's why we call them absorption lines. For example, sodium is missing parts of orange light, and for iron, parts of blue and green. Based on the pattern of lines, astronomers can now recognize which elements make up the matter of a celestial body, as well as what the temperature of its gaseous atmosphere is. They can also determine the distance and movements of stars, and even entire galaxies. Today, there are around 25,000 absorption lines that are known in the solar spectrum. Their discovery was considered to be a milestone in astronomy because our knowledge about the universe is almost completely obtained by the analysis of light. We owe this knowledge to Joseph von Fraunhofer, the pioneer of the spectral analysis. Without his discovery, we would never have gotten so far in the development of physics as we have today.